Right, so section 6.6, we already talked about kites, bless you. Today we're going to talk about trapezoids. So first let's do definition of a trapezoid. Trapezoid has a super easy definition. It's just one pair of parallel sides. Okay, based on that information, is it a parallelogram? How many pairs of parallel sides does a parallelogram need to have? 2 pairs, right? It needs to have 2 pairs of parallel sides. So a trapezoid only has 1 pair. So trapezoid is not a parallelogram, just like a kite was not a parallelogram. So we're going to draw a parallelogram, which has, and I'm going to draw it top and bottom as parallel. I'm going to put the little caret. The 2 sides we're going to call legs. Okay. The top and the bottom we're going to call bases. So this right here is a base, and this right here is a base. It's usually denoted with like B1, B2. And sometimes your trapezoids will be drawn turned like 90 degrees, so it might be on the left and the right. But it's the 2 sides that are parallel that are going to be called the bases. The other 2 sides, this side and this side, are called your legs. Those are the main features of a trapezoid. There are also angles. The angles are called base angles. So you have 2 pair. And if it's drawn, so that the base 1 and base 2 are at the top and the bottom, then you're going to have a pair of base angles up here. I'm going to shade those in pink. And then you're going to have a pair of base angles down here. I'm going to shade those both yellow. Okay? These 2 are a pair of base angles, and these 2 are a pair of base angles. These 2 go together, and these 2 go together. Okay? So the one I just drew is just a non-specific trapezoid. Once you start getting more into trapezoid, you're going to get a very specific one called an isosceles trapezoid. Where have you heard the word isosceles before? On a triangle, right? And the triangle that's an isosceles has what? 2 congruent sides. So on a trapezoid, what's going to happen is, besides the bases, you're going to have those 2 legs. On an isosceles trapezoid, those legs are going to be congruent. Okay, so we're going to draw it a little bit fancier in just a second, but your legs are going to be congruent, which is going to force your base angles to be congruent. All right, there are also some properties about trapezoids that you need to know, okay? The first property, I'm going to read it to you word for word, and then we're going to draw a little picture. So first property says, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent, okay? So we're going to draw the very specific isosceles trapezoid so that the left leg in this case and the right leg are congruent. So we're going to put tick marks on each of them. We also have parallel sides, making it for sure a trapezoid. And if we label the vertices, we'll go with A, B, C, D on this one. This theorem says that angle A is going to be congruent to angle D, and angle, I meant to write D right there, sorry. I said D and wrote B. And angle B is going to be congruent to angle C. Okay, so kind of how I shaded it in up here, the A and the D are going to be congruent, that pair of base angles, and the B and the C, that pair of base angles. Okay, they're both base angle pairs, and on an isosceles trapezoid, they're congruent. On just a regular old non-isosceles trapezoid, they aren't necessarily congruent. In fact, they're not congruent. Okay? All right, there's another theorem, theorem number 2. And here's what it says, that if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. Okay, so we're kind of turning theorem 1 around. It's almost the converse, not quite. It says that in a trapezoid, where you have one pair of parallel sides, and we'll label it A, B, C, D again. This theorem says if angle A is congruent to angle D, then it is an isosceles trapezoid. Okay, so here's A, here's D. If they're congruent, then it's going to be an isosceles trapezoid. So theorem 1 and theorem 2 are just kind of converses of each other, except for this one tells you that both pairs are going to be congruent, and then this theorem says if one of them are congruent, then it's for sure an isosceles trapezoid. Okay. Third theorem for trapezoids says this: a trapezoid is isosceles if and only if its diagonals are congruent. So we're going to draw another trapezoid. We'll label it A, B, C, D. And because this theorem has to do with the diagonals, we're going to connect A to C. We're going to connect B to D. And we're going to put tick marks on each. BD's tick mark, AC's tick mark. This theorem says, bless you, if AC is congruent to BD, then it is, same as above, an isosceles trapezoid. I'm going to move this up. You'll see it in just a second. There it is. All right. So let's look at a couple examples. Example number 1. I'm going to draw you a trapezoid. This one I'm going to draw sideways so you get used to seeing it at a different rotation. We'll go with A, B, C, D. And here's what we've got. Angle C is 100 degrees. Angle D is 100 degrees. We're going to find the measure of angle A. All right, so first of all, we know it's a trapezoid because we have the parallel, the parallel sides, the one pair, and we have angle C is 100 and angle D is 100. So if we have one pair of base angles congruent, what type of trapezoid do we have here? Isosceles. So we're going to put a tick mark here and a tick mark here, which means that it is for sure an isosceles trapezoid. Bless you. And if we have one pair of base angles congruent, then guess what? Our other pair of base angles are congruent. So we don't know this one and we don't know this one, but we know that they're the same, okay? So we're going to use an X, or you can put a question mark, however you want to label it. So we have X degrees, 100 degrees, 100 degrees, and X degrees. Anybody know the total degrees in a quadrilateral? 360. Okay, so if a quadrilateral has total degrees of 360, we can take all four of these angles and add them up to get 360. So we know there's 100, 100, and then X and X. All right? So now we've got a pre-algebra problem here, right? We've got some variables. We've got an X and an X. That's how many X's? 2 of them. We've got a 100 and a 100. That's easy. 200. Subtract that 200 from both sides. And we have 2x equals 160. And then the inverse operation of multiplying by 2 is dividing by 2. So x is equal to 80. Okay, that tells us that angle A is how many degrees? 80. What if they also ask us for angle B? 80. Okay. Any questions on example number 1? That one was pretty easy, right? So let's throw a little bit of algebra in there since it was so easy. Example number 2. Angle P right here is a squared plus 27. And angle S right here is 2a squared minus 54. And the directions just say solve for A when PQRS is a isosceles trapezoid. PQRS, isosceles. I'm just going to put ISOS. You guys know what ISOS is? Isosceles. Okay? So if it's an isosceles trapezoid, then obviously these two sides are parallel. That makes this side and this side congruent. So this base angle and this base angle are congruent, right? So we've got this algebraic expression here, this algebraic expression here. So I'm just going to put an equal sign between them. I'm going to say that 2a squared minus 54 is equal to a squared plus 27. And I'm noticing that I've got a term with a squared on this side and a term with a squared on this side. So this one's larger, so I'm going to subtract the a squared from both sides. I also want to move that 54 over here, so I'm going to add 54 in the same step. But you could technically do that in 2 steps, right? These are opposites, they cancel. These are opposites, they cancel. 2a squared minus 1a squared leaves us with a squared. And then on the right, we have 27 and 54. Anybody got that one? 81. There's your 81. Do we like 81? Yes, because if this is squared, the inverse operation is to do what? Square root. So I'm going to square root both sides, which tells us that A is equal to 9. It's also technically equal to -9.